Hello and welcome back. We just finished talking about the formula for mutually exclusive and non-mutually exclusive, and they're really the same formula. You can put, like I said, this formula right here, you can put it on your formula sheet, and it covers all the formulas, or it covers both cases, just remembering that that third term will go to 0. Final example then, before you get started on the homework. Company is testing a new product to see if it requires a surge protector. The tests show that a voltage spike has a 0.2% probability of damaging the product's power supply, a 0.6% probability of damaging downstream components. So when you sit back and you try to decipher this, the 0.2% probability of damaging a product's power supply, so that is just the power supply, so it's basically frying your computer, for example. Then there is a second probability of downstream components being damaged. So, oops, back that up a little bit. So that means that if there's a voltage spike and your computer is hooked into the wall, the same circuit as, say, your printer, there's a 0.6 probability that your printer will get fried. And finally, there is a 0.1%, so they're giving us a third probability here, that both the power supply, so your computer, and the printer are damaged. So in this particular question, there's overlap, okay? So we are looking at a non-mutually exclusive event. So let's set up our sets to begin with. So the power supply will be set A. Oops, can't spell. It's a good thing I'm doing a math video. And now I have highlighter. That's even better. And power supply. B part is the downstream components. So that's things that are hooked into the wall. Downstream components. So if your computer fries, or it could be something that's hooked up through the computer. So let's say your iPod is charging on the computer. There's a 0.6% chance if there's a spike, it's going to get your iPod. So if I do this as a Venn diagram, and this will help some people are going to jump right to a formula, which is fine as well. But to help you with this Venn diagram, or using the Venn diagram, we have set A. So this is your computer. Set B is your iPod being fried. We know there's a 0.1% probability. So this part of the question right here, okay, that both get fried. So you lose both your iPod and your computer. So there's your 0.1. It would go in here. So people that are really understood and comfortable with Venn diagrams, you can always do mutually exclusive and non-mutually exclusive with a Venn diagram. You don't even need the formula. Because if we do set A is just the power supply going. So that's the 0.2 right up here. So in here, it's going to be 0.2 minus 0.1, because remember, inside the whole A bubble is 0.2. All right, so remember, it's like the when you're doing the Venn diagrams with 3 sets and you're breaking it down. So it's actually 0.1 that just the computer will get fried, because 0.1 of that is both get fried. And on the other side, there's a 0.6 probability, okay, that both things get zinged. But remember, downstream component gets zinged. Remember, there's already the 0.1 in that bubble, so it's really just a straight 0.5% probability chance that the downstream component. So you can answer the question from the Venn diagram. What I want to show you, though, is the probability of A or B occurring. So A or B from the Venn diagram would be 0.1, so just A, or B. So it's going to be 0.1 plus 0.5. The answer should be 0.6. And we can confirm that with our formula. So for people that prefer the formula, so event A, and you have to make sure you do this component on tests. You might as well get in the habit of doing it in the homework, because this is what I'm looking for. You need to tell me what A and B are, because you're not going to write out probably a power supply inside the bracket or downstream components. Too much writing. Minus your overlap. So this is the formula from the previous page. So probability of A is given up top there. it would be your 0.2 plus the probability of a downstream component is 0.6 minus the overlap, which is 0.1, because both of them would get counted twice. When you do the math there, whoops, 0.7%, and that's my mistake over here when I was talking. 0.1 plus 0.1 plus 0.5 should be 0.7. I forgot to do the overlap. So therefore, there is a 0.7% chance power supply and component get zapped. All right, and again with the Venn diagram, okay, my apologies there, because you're looking for the OR situation, so the overlap was being counted twice. So 0.1 that it is just your computer, 0.5 that it is just the hooked up component, and then the 0.1 for both of them getting zapped, which is still in that OR situation. So you end up with that 0.7. All right, so either method will work, Venn diagram or formula. A lot of people like the formula. Try the homework. If you have any questions, please make sure you come and see me, and we'll get them straightened out prior to the test.